found these rich solar panels that would just barely fit. It was like a very slim fit, but it would fit into the roughly 21 inches of widthwise space that I had on either side of the fans. And I figured out that I could get 4 of those installed. So 2 beside the front MaxxAir fan, and then 2 beside the rear MaxxAir fan. From there, I ran some calculations to determine exactly what the solar circuit would look like. So I knew I had purchased a 540 amp hour 12 volt lithium battery bank, and I calculated in a 40% loss from cloudy days and winter weather. So I came up with a power pack of 9,072 watt hours. So that's how much battery I would need to recharge. So if I had 400 watts of solar, I knew that it would take around 22.5 hours to recharge that battery bank. So assuming there were 6 hours of direct sunlight in a day, that would take a little less than 4 days to fully charge the battery. So I had 4 100 watt solar panels planned. I'd connect the top 2 in series and the bottom 2 in series, and then I'd connect those 2 pairs of panels in parallel. And I chose to do it this way because that would make sure that the voltage of these panels would be 45.5 volts, and that would make sure that even on cloudy days, the kind of nominal voltage would be plenty to charge the batteries. Even if the panels were partly shaded, you need a certain voltage in order for the batteries to properly charge. So I wanted to make sure I hit that voltage. So next, I spent entirely too long just researching everything about these solar panels. I learned all about the fuse rating and determined that I needed to add an inline fuse to each of the lines to protect damaging the panels. Then I went over into Figma and created this super high resolution design of like the solar panel circuit, including the branch connectors and the inline fuses and the cable entry housing and kind of exactly where all of the different wires would run. This just helped me visualize exactly how I was going to hook this all up. Next, I went in and did a deep dive on solar charge controllers to figure out, given the specs of my panel and the current and voltage of my lines, what charge controller I would need to install for my electrical system. And then finally, I felt like I had all the research I needed, and I grabbed the ladder and ordered all the panels, and I began the solar panel installation. So when I came to check everything out the next day, I realized that I'd only put my adhesive on the very top of the cable entry housing, and it was still wiggling around and felt pretty loose. So I decided to take it all off and kind of redo the installation. This time I put a ton of adhesive on the bottom of the cable entry housing, and then I added 3 screws to secure it to the sheet metal of the roof, and then I just put a ton of Sikaflex adhesive all over the top of the housing, just to make sure that no water, no rain could get through. I didn't want to have to try to figure out if there was a leak later on or undo this later, so I decided to make sure that it was the first time. And then once I had all the solar panels installed, I went back to Adobe Illustrator and I started modeling out all of the branch circuit wiring paths for the interior of the van. So starting from the electrical system installation area in the van, I modeled out where the different wires would run and the rough paths that they would take to get a general idea of exactly where and how many and what wires I would need to install. So after a while, Adobe Illustrator just became way too confusing, and it wasn't the right software for what I was trying to use it for. So I switched over to this app called Draw.io to get into more details for all of the electric circuits. And I started drawing out exactly where all the electrical components would live and how they would be connected together. So right here I'm connecting up the rooftop light circuits for both the bedroom zone in the rear of the van and the kitchen zone in the front of the van. The orange squares that you see are called Wago nuts, and they're a way to splice wires together. And I tried to just label all the different circuits on this diagram so I could really recognize what was going on. Then I started doing a bit of research on the 12-volt DC panel that I would use. My plan was to have one on the driver's side, right near the batteries, and then an auxiliary one on the passenger side. And this would make it so all the passenger side circuits would have less distance to run for all the branch circuits. So I could use thinner wires and have less voltage drop. And I think probably the hardest part of this whole thing was trying to plan out these 3-way light switches between the entry of the van and right next to the bed. There's so many wires involved. It was kind of crazy to draw out. I'm starting to plan out the pre-wiring for the van, and so what that means is determining where exactly all of the wires need to run throughout the van, where all the electrical loads and different components are going to be, and then determining the wire paths and the exact lengths of those wire paths. So what I've done is I've gone through the van and I've kind of taped out locations for lights, fridge, oven, switches, outlets, just all the different electrical branch circuits. And I just created this rope marked off with 1-foot increments, and I'm going to go and try to figure out exactly what wire path I want to take from the battery system or the fuse block to that component. It's really important to know the pretty precise distance between like the power source and the component so that you can figure out what gauge of wire you need to run. The longer the distance, the thicker the wire gauge. And then once I get this all figured out, I can actually order all my wires. just finished taping out all of the different component locations and wire paths with masking tape. And I created a spreadsheet of all of the different loads that I'm going to use, the different wire types, where the wires are coming from, the voltage and amperages of the components, and then the single trip, just positive wire lengths in feet. And then I'm going to do a bit more calculating related to voltage drop, like 3% voltage drop, 10% voltage drop calculations, and then from there decide what wire gauge is appropriate for each of the wires I'm running, and then group those into more common wire gauges so I don't have to order a ton of different wires. I'm going to have the electrical system live over here. So I'm going to have a 120 volt breaker box and a 12 volt driver side fuse block. Wires over to the oven here, to the alternator charging right here, gasoline heater down below that seat. I'm going to loop a 120 volt wire right around here. Have one outlet, two outlets, three outlets. And then I'm going to run a outlet back here for a 12 volt socket. Across the 120 volt from the breaker up and over the van, down through here. 120 volt socket here. Then I'm going to have a second 12 volt fuse block on the passenger side to reduce the wire lengths running from this side. From here, I'm going to run out wires for the rear MaxxAir fan, the front MaxxAir fan, Weboost cell phone signal booster, run a wire down for the fridge, run a wire for the water sink pump, two 12 volt outlets, one right here, one right back here, and then the most confusing thing in this whole process was trying to figure out this. It would have been so much easier just to use a single switch, but my plan is to have three-way switches for the kitchen and bedroom with a dimmer for each zone, both here and down here next to the bed. So the idea is, like, when I'm in the kitchen or coming into the van, I could flip either of the switches on from here when I'm working over here, and then when I'm in the bedroom, maybe in bed, I can flip both switches off here. So in order to do that, there's this crazy wire path. I won't go into too much detail here. Maybe I'll show a diagram or something, but I need to connect both of these switches together and then run wires up to fan out into lighting zones up here for the kitchen and a lighting zone up here for the bedroom. That's going to be the most wire. These switches require two kind of positive signal cables to run between each switch. So there's going to be, like, probably, I guess, a total of 6 wires running between each of these switches, and then continuing either onto the lights or sourcing from the fuse block. So I'm about to start running wires all throughout the van. It's called, like, rough-in wiring or pre-wiring. Just got all the wires delivered. Got a few more checks to make with this rope that I've marked out at 1 foot increments to just double check the wire lengths. But I should be able to start running wires all over the van. Yesterday with some frustrations around different wire gauges, especially around this fuse block. So I got this Progressive Dynamics PD60 fuse block that has all these terminals in the front and the back, and it looks like a great block, but the power input terminals are pretty small, and so are the output and the ground terminals. So I got this probably really oversized 2-gauge wire that I wanted to get so I would avoid any voltage drop running to this secondary fuse block, but the terminal wouldn't accept 2-gauge wire. So I'm now having to return this 2-gauge wire and this 8-gauge wire that I was going to use for the refrigerator, and I'm going to switch that with 10-gauge wire and just kind of hope for the best. But it's pretty frustrating. I ordered 4-gauge wire, so I'm hoping the 4-gauge fits in here and in the ground terminals. But yeah, it set me back, and now I gotta wait before I can wire any of this stuff or do any of that pre-wiring.